Bismillahirrahmanirrahim. Assalamu alaikum. Let's start sets. Initially, basics of sets, and with a reference to chapter 14 of D2. Okay, now the first thing is, what is a set? Set. So, when we say set, it's a collection. Okay, what kind of collection? It is well defined. Okay, and this well defined collection is also distinct. For example, if I say students of class 10, okay, students, it's a collection. I'm saying students of class 10, well defined collection, and each and every student of that class is distinct. So I got a set of students of class 10, right? Let's take another example. Name of months, and I am going to take a set of name of months whose month name starts with J. Okay, let's say M is equal to. Now the thing is how I'm going to make a set of month names starting with J. But how are we going to represent this set? To represent any set, we need curly braces. The set is, to represent a set, we need starting curly brace and ending curly brace. The objects enclosed within those curly braces makes a set. Okay. Now the set can have objects in it, and these objects are known as elements of set. Like as I said, that the collection of class 10 students, each and every student is element of that set. Now I'm going to write a set of month names starting with J. Now each name is going to be the element of the set of months starting with J. So what I need is starting curly brace. I'm going to write first name. Now after writing first name, to distinguish it from the other, I'm going to put comma, and then the second one is June, and then July. Okay, this completes the elements of set. I cannot have any more month because none of the other month starts with J. So this is complete. So ending curly brace. So it's a set of month names starting with J, and each and every name in this set is element of this set M. Okay, and there is a mathematical way of saying things as well. So if I want to say this January belongs to this set M, so how am I going to say this? January belongs to set M. Now this is in English, so how to say in a mathematical way? So it is January belongs, and I'm going to use epsilon, a Greek symbol which represents belongs to set M. So, okay, it's a collection, it's a well defined, it is distinct, it is represented with curly braces, and to see which element, which object belongs to this set or not, we can use sign epsilon. Okay, now if I say May, does the month May belongs to this set? It doesn't. So may does not belong means this way, does not belongs to set M, right? Okay. One more thing. If it is possible that the set does not contain any element, and what is that situation? And that situation is that set is empty, and the empty set is represented with this two curly braces or phi, another Greek symbol phi. Okay, so it's an empty set. This set has objects within it or elements within it, and this set doesn't have anything, so it's an empty set. Okay, or we represent it with symbol phi. Okay, so let's move further. Now, this set has 3 elements in it. So the number of elements or object within the set are represented by lowercase n. And if we are going to talk about this set, I'm going to say the number of elements within the set M equals 3. So it means that this is a way of expressing how many elements or members are within this set, right? So in this set there are 3 elements. So if we say nm, number of elements within the set M equals 3. Okay. Now the next we come to set notation. Let's talk about this. Now, coming to the set notation, suppose I'm going to talk about a set of all positive integers less than 15. Set of all positive integers less than 15. So there it's something, this information is in English, so how to represent in a mathematical notation so we can understand it, what kind of a set it is. So the way of writing this set is, let's suppose that we are representing this set with O. So O equals, sets are represented within the curly braces. So, and let's say X is representing each and every element within the set. So X such that, this column here is such that X such that X is X is positive integer less than 15. So it's a notation, way of expressing how we express things in a set notation. X such that X is a positive integer less than 15. Let's take another example. Set of all even integers less than 15. Okay. Now let's say I say E equals X such that X is even, and also let's mark here even, positive. Why I am doing this? Because integers are negative and positive both. So even, positive integers less than 15. Okay, now this is expressed in set notation, and now let's write the members, the elements within this set. So E equals less than 15, positive ones, 2, 4, 6, 8, 10, 12, 14. Okay, we may add 0. Sometimes the 0 is the member also. Okay, so this was about the set notation. Let's move further. Okay, now let's talk about universal set. Okay, universal set is a set which is a collection of all the objects and all elements, of which all the other sets are subset of this universal set. Okay, this is the bigger set, and all the other sets are subset of this universal set. What is a subset is part of that set. We'll talk about subset later, but let's talk about universal set. It's a set of all the elements or objects, and all the other sets are actually the subsets of this universal set. Of course, we are talking with reference to something. We are talking about a universal set of all the integers, right? And then we say set of positive integers. It is a subset of this universal set which contains all the integers. If we say set of negative integers, the set of negative integer is a subset of a set of a universal set of all integers. Like if I say, and this universal set is represented with U or Z. It's like this, Z. Okay, universal set. And if I say equals X, say that X is set of all integers. Now it contains negative and positive. So now, and if I say P equals X, say that X is set of all positive integers. Now, obviously, this is a bigger set. It contains negative and positives. When I say P, it's a set of all positive ones. So that means this is part of this. Okay? So this is a superset, like a universal set, and this is part of this universal set. Okay? So this is a universal set. Now let's take an example of a universal set and a set. So, and let's see how we can represent through a Venn diagram as well. Okay, now I have a universal set. X, say that X is an integer between 5 and 15 inclusive. Okay. Now first, before going ahead, what numbers are members, elements of this universal set? So U equals, here it says inclusive. It means 5 and 15 are included. Okay. So and integer between 5 and 15. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And I have another set, let's say B X, such that X is a prime number. Now this set is with reference to this universal set, okay? And so B is going to contain, I'm going to see which are the prime numbers from this universal set, which are 5, okay, 7, 11 and 13. Okay, now we have to represent this thing through a Venn diagram. Now, what I'm going to do is, first I'm going to represent these numbers. This is B, and the prime numbers 5, 7, 11, 13. And remember, when you are drawing a Venn diagram, don't put commas in it, and it has to be very neat. Okay, this is U. And now I have to see what other than this is remaining. So starting with 5, 5 is already there, then 6, 7 is there, 8, 9, 10, 11 is there, 12, 13 is there, 14 and 15. So this completes our universal and another set which is a subset of, so this B set is subset of universal, right? Which is a part of that universal. This is set and this is universal set, right? So we can have the idea what I meant by saying this set, all the other sets are subset of a universal set, because when I took this as a universal set, I said integers between 5 and 15 inclusive, and then I said B are prime numbers. It is a set of prime numbers between 5 and 15, but it's a subset of this universal. Okay, and I have represented through a Venn diagram. Okay, you got the basic ideas about the set, and in the next session I'll discuss more about the set with the reference to Venn diagram. Okay, thank you very much.